Swayam Prabha. Digital India. Educated India.
Dear students, we are in the 9th module of the course Fire Safety in Buildings. So, what will be the contents of this module? It is covering assembly buildings, heritage structures and also museums, airports, underground metro stations and industrial buildings. Now, I have tried to bunch them like assembly building will have various buildings where assembly or gathering of people happens. Heritage structures and museums were actually either very old buildings or buildings where very old items are kept like sculptures or paintings or exhibits are kept. After which is the airports, which handles a lot of passengers, but also and is a very expensive zone, and any loss in these kind of areas should be known how an architect should design or keep in mind. Underground metro stations, these are carrying passengers in bulks. So, that is also another zone where students or those who are in the profession need to know as an architect what should be the way forward for design or starting the design. And lastly comes the industrial buildings, which are mostly under the hazardous buildings, which NBC gives a clear guideline, though we will be trying to touch upon these areas in this lecture. So, first we will start with the assembly buildings. As you see, it is mentioned auditoriums, public entertainment spaces like it may be restaurants, exhibition areas, etc., all come under the category of assembly building. Now, on these particular kinds of buildings, it is expected that the number of people or the users will be large in number, and as I have told, they are not as I have already discussed that people may not be oriented to the building. So, for auditoriums or public entertainment spaces, people may be coming for the first time and say they happen to come across a fire, and they should be given proper directives for escape, which is the first and foremost to that is the objective of our designs. That should be, it should not harm any life or should not take any human life. So, considering that, we will see that NBC has divided or subdivided the different types of spaces under this category under D1, as you can see D1 to D7. So, there are D1 to D7 types of subdivisions, and each of them has various explanations, that is fixed seats for over 1000 people, up to 1000 people. So, what we see, it is the number of people being handled in such buildings. Buildings with permanent stage having accommodation for 300 or more persons, but no permanent sitting. That means, there will be chairs brought in and they can be taken out. So, it is a kind of hall where there will be more than 300 accommodation, but they will not be of permanent nature. Now, why are these told? Because how much is the free space for moving or getting escaped is also very important in such kind of designs. Buildings without permanent stage having accommodation for less than 300 people. So, this is again another typology without a permanent stage. The upper one was without a permanent stage having more. All other structures, including temporary structures designed for assembly of people not covered by other subdivisions at ground level, are coming under subdivision 5. And under subdivision 6, you see we have shopping malls, mercantiles, cinema theatres, multiplex and restaurants, and also food courts. Under subdivision 7 are the underground and the elevated, like partially it is below the ground and partially over ground, that is semi basement kind of occupancy. Now, all these buildings which are made for a purpose of public gathering must be having what other criteria that has been discussed so far in my previous modules, that they should have the provision of materials which should be fire rated. Here also we will see they should not have any toxic fumes spreading due to burning process. The first two categories which were having stages needs a stage roof for every theatre, and the stage roof should have a ventilation system and operable from the stage floor, so that any smoke that is built up in the stage area gets vented automatically, as the smoke will be on buoyancy, it will be going higher and higher and it should get an exit. Any combustible material or equipment for staging up the set, for setting up the stage should be rated and should be taken off from the assembly area, because there actually the most of the people are getting gathered. Now, as you see, combustible materials or equipments for painting, refurbishment, repair of similar purpose shall be effectively cut from the assembly area. So, they should not be kept as a storage or in any format nearby the assembly area, and also away from any staircases or exit routes. So, any exit route, may be lift or staircase, should not have a storage space. So, when you are doing the architectural design, storages should be away from the assembly areas or gathering areas. That could be the lobby space or in front of the staircase or the lifts. Fabrics and papers used in the stage setting. As you all may have experienced a drama or a performance in a theatre area, there particularly the fabrics or papers are being used to create a setting, maybe of a jungle, maybe of a palace or something. So, these kind of stage settings should be made of flame retardant material of class 1 flame spread index. Now, these are mandated and these are to be followed for appropriate safety measures when any theatrical performance is happening. You also take a note that any food producing items, that is canteen, where there is a flame, they should be kept away from the zone where the gathering of the people is expected. So, in the foyer or the lobby space, just annexed to it, there should not be any canteen, because any kind of fire hazards can start from the fuel which is present in this area, which can be used in this area. Now, under the NBC, assembly building comes under group D, and a series of requirements for the exit door, for the number of exits, for the width of the exit, for the capacity of the hall, for the width of the aisles. Aisles means the passages through which the people will run off, number of seats when it is a fixed seat. All these are mandated within the particular section of assembly buildings under fire safety. Now, why are these made? You can see some more. If there is a balcony or a gallery within the auditorium to accommodate more number of people, because you had seen it is more than 1000, less than 1000. So, automatically the concept of balcony or gallery will be coming, and there you see the railing height not less than 1000 millimeter high should be provided. So, safety in case of fire in that area, people should not come out of that area, and that is why such heights are also mandated. So, following each and every item is required. Again to note, there should not be any turnstile or other devices to restrict movement of people, because in case of an emergency people will try to come out, but to give a control of the ticketed observants or the ticketed audience, there can be a plan of putting a turnstile gate, but that should totally be avoided in case of a auditorium design. From the design point I am telling. So, no displays and exhibits to be kept in any area where no displays or exhibits shall also be installed in the way, in any way having any required exit sign. So, you must always be careful for advertising. You can put up a board, but not covering the exit sign, because these are the routes or the signs that will glow in case of an emergency, and they will give or navigate, help navigate the people for safer routes, safer zones. So, here if I show you, if this is a plan of an auditorium accommodating a large number of audience, it is told that in this particular length there should not be more than 13 seats. So, from the central person we will have to cross 6 people either side to come out to a safe route, which is the aisle. Similarly, on these smaller things where they can come out in 2 directions, no more than 7 people or 7 chairs can be put. Now, in this case you remember the chairs are fixed. As I told you, if the capacity is beyond 1000, there should be minimum 4 exit routes, and they should have signages for their going out. As I told you, in case of balcony, if this is the stage and this is my floor, and then on top there is a balcony projection, these kind of seats are there, and this must be having a railing height of 1 meter minimum. Now, this stage should also have some vents on the top to pull out any smoke in case of fire. These are to be mandatorily followed. So, this is my maybe the building. Now, you understand that audience will be coming to this level. So, automatically there will be staircases around, and these staircases should not be guarded by entries or exits of storage spaces. So, in case of fire, the people should be ready to come out and take exit. This is the auditorium space. So, this will be the foyer space, and there may be staircases in these locations to go up to these balcony levels. So, no canteen, no storage should be encroaching these exit areas, these routes for exit. These were some more points. If you can see, seats in places of public assembly more than 300 persons shall be secured fastened to the floor. Now, with this fastening and non-fastening, the main point is, as we were discussing, this is always for when the people, this number 7 of people crossing the number 7 people is only for chairs which are fixed, but if chairs are flexible, then there will be no aisle, clear aisle, because these are the only routes for movement. But if there is no seats fixed to the ground, people can move out just pushing the chairs and they can come out to the exit points. Other than that, no open flame lighting. Say it is a inauguration, sometimes for ceremonial purposes with permission only flamed lights can be put on, that is open fire can be, open flame can be used in case of an auditorium accommodation. So, candles may be used on restaurant tables, but it is to be also on a non-combustible base. So, the base has to be non-combustible in nature. So, you see, for ceremonial purposes we have the lighting of the lamp, which may be an open fire. In case of restaurants it can be candles, but it should be on non-combustible base. Open flame as part of theatrical performances providing adequate precaution also needs permission, because the firefighting people, the people trained in firefighting or the building administration remains aware of the fact that there can be a case of fire. Other than these, all auditoriums and public gathering spaces should have sufficient signages for escape to a safe point or an assembly point, like all other buildings we have discussed, or principally we have discussed on shopping malls, on restaurants, on assembly buildings, that is auditoriums, that should be also maintained. With that, we move to the next type, that is heritage structures, which also includes museums, which are old structures. Now, after completing the assembly buildings, we come to heritage structures, which are very old in nature. Very old structures may be made with wood, that is also a point of concern, and in many cases there are labyrinths kind of zones, that means interconnected spaces. As you see, there are often labyrinth layouts, like one room leading to from one room you enter into another room. So, this is room 1, you enter into room 2, and from there again you enter into room 3, or maybe from there again you turn, there is room 4, and so on. So, they are linked, which helps or which stops in the process of compartmentalization or compartmentation. So, the basic concept of fire fighting, that means fire prevention, was compartmentation and pressurization for smoke venting, but that key point is cannot be taken care in the case of heritage structures. In most of them they are connected spaces. Now, you can put a filler material to close that gap or to close the between the two spaces, say some filler material between 1 and 2, between 2 and 3. But then what will happen? The material will not match. Also, the purpose or the connectedness of the 2-3 zones, which was the primary thought when this heritage building was declared as a heritage building, that will be tampered. So, we just cannot make walls without permission of the authorities who have tagged it as a heritage structure. So, appropriate for doing any retrofitting, that means any change within the building, permissions are to be sought. Also, as I told you, old buildings means wooden framing which can lead to fire. the labyrinth layout, it is also difficult to navigate in case there is a fire. So, people will be running between spaces and will always look for the exit or maybe not ending up to the exit point. So, they might be getting stuck up in one zone because they are under panic. So, it is very difficult in case of heritage fire in heritage buildings, very difficult for evacuation. So, evacuation plan should be planned by creating panic situations and trying to see where people can get stuck up, and appropriate planning measures are to be, that means design corrections are to be made within the structure. Also, words of concern are the hidden crawl spaces. Many heritage structures may have a sloping roof. Now, you see some temples, there are lot of crawl spaces where people cannot access, but there are connected spaces at the roof level, some attic spaces, gaps between walls, behind walls, hidden pockets where fire can spread undetected. So, when a heritage structure is revisited for fire safety or fire prevention retrofitting planning, all these kinds of spaces should not be neglected or kept out of scope, because these are the points from where fire can move from one space to the other. Needless to say, we had discussed this in length for services plans. Now, heritage buildings do not have such service routes, they do not have air conditioned ducts, they do not have proper electrical wiring system. So, these are also points like old electrical wiring system without an miniature circuit breaker, MCBs, that can also lead to fire, because MCBs in modern buildings are put to stop electric current to a point if there is more drawing of electricity. So, all heritage buildings, for all heritage buildings, a relook into if the electric line can be improvised or MCBs can be added should be one of the concerns. Also, as I told, exit evacuation plan should be made by creating scenarios that there is a fire. Based on that, the internal planning has to be restructured. So, challenges in retrofitting: installing modern fire suppression system. It is also a challenge because there is no provision of fire suppression system. You have to take holes for pipes through the walls. So, you are actually tampering the building. Space constraints are there. Damages to historic features can happen because of planning for a route. Electrical wiring, as I have already addressed, it is outdated, overloaded and without any miniature circuit breaker. If it is repurposed for some other use, like many heritage buildings go for a retrofitting to a restaurant or to a library or to a public space, proper fire safety measures should be taken before it is taken up for new occupancy. Egress analysis should be done. Additional staircase may be added. Now, many heritage structures we can see that there is an additional provision of a staircase which is abutting out from the building from the main building surface. Now, this is to provide the adequate number of staircase which can save people in case of an emergency. Considering heritage buildings housing materials which may be age old, or maybe museums which has age old sculptures or paintings there, we usually plan for water mist suppression system instead of a of a deluge kind of sprinkler system, that is less amount of water will be demanded, because these kind of historic buildings also do not have any static underground tank, neither it may be having a static overhead tank. So, these are features are to be added into the building to make it fire safe, and in case of fire it should be equipped for the protection. Installing voice evacuation system is required, so that immediately on in case of a fire or a detection of a fire, the voice evacuation speaker starts speaking, so that the people who are in the heritage building can come out with sufficient amount of time, because egress is the key issue which is a problem in this kind of buildings. So, heritage buildings should have appropriate retrofitting measures to keep it safe from fire and keep its exhibits also safe from fire, so that there is no damage to the people who are coming as visitors, or also the exhibit items or the value which it contains, that can be protected lifelong or further over time. Now, passive system and active system both can be adopted in such structures. Compartmentation, as I told you, like chamber A to chamber B, if it is connected, it is very difficult to create a compartment. If they are having connected functions, it is very difficult to close down. Also, respect should be there for the material selection. As you see, we can put gypsum board partitions, applying fire retarding coatings on the existing wood surfaces. So, the existing wood surfaces can be having fire retarded coatings to ensure that they are safe from fire. However, you remember for this kind of buildings, there should be respect for the color, texture, compatibility with the historic materials in that space, in that heritage building. It is also same for a museum building. Electrical routes can be changed, MCBs can be installed, yes, but that also needs careful replacement. Flammable materials to be avoided, storing of any flammable materials cannot be allowed in any heritage building. So, coming to the active systems, as I already told, water mist system is the best, that has very low water demand, but very effective. It is having low water demand, that saves the static water storage capacity as well as the overhead water storage capacity. At the same time, the exhibits are also not drained with water, because the value of that exhibit also has to be recognized. So, with this I think we come to the end of the heritage buildings and also the museums, where some heritage items are preserved. And now we move to another important area, which is the airports. Now, very recently in June 2023, there was a fire in one of our national airports, and after visiting such situation, after coming across such a situation inside the airports, you can see the the emergency exit plan being placed on the internal airport walls. Now, in this, usually the airport has one side where people are coming by cars and getting dropped off, and the car is moving out or going to the parking. Other is the air side, where the aeroplanes are on that side, and passengers when they are dropped off on this side cannot go directly to the air side. That is the principle of an airport. After proper checking in this zone, so they enter into this zone which is the city side zone, and once they get into the air side zone, they cannot come out to the city side zone. Also, when they are in the aircraft, they cannot exit on their own, or when they are in the process of boarding, they cannot come out from that area. So, in that case, evacuation becomes a difficult task from the evacuation point of view. As an architect, we have to think of the three broad areas, that is, one is the terminal area which we are talking on, other is the baggage handling area, because once you are on the city side and taking your ticket, you are handing over your luggage which has a lot of cellulosic items, and that goes into another zone where we cannot have any access as a passenger. The third zone is the air traffic control, where a very minimum disruption cannot be allowed, because that is controlling the air traffic movement. So, with this understanding, you can understand each of these planes in their aprons are standing, and they are charged with fuel, and at any point of time there can be a case of fire during flight alighting or boarding. There can be case of fire and various internal reasons from electricity etc., there can be fire. So, this is a very recent picture, this is a very recent incident and the picture, and the area fire zone is an area or region of an aircraft designated by the manufacturer to require fire detection and or fire extinguishing equipment and a high degree of inheritance of fire resistance. So, where my flight is standing, there is a zone beyond which within which all checking has to be done before a flight is moving to take off. So, detection points and return air grills in these kind of zones where this aircrafts are stationed, that is the apron area, the nearness, the building facade in the nearness should be very well designed. It may be glass, it may be panels of metals which are to be very safe from the fire. So, they are to be very high fire rated material. If it is glass, it should be tempered glass. If it is panels of metals, one has to be using very safe metals. So, safe metals which will not catch fire very easily. So, airport buildings, efficient building envelope, fire safe facade cladding materials are to be chosen. Facade and roof focuses on high performance. Facades and roof both should focus on high performance building facades. Interlocking panel cladding with GFRC, that is glass fiber reinforced concrete, extruded terracotta cladding, fiber cement board cladding in relation to the reaction to fire behavior, that is its non-combustibility rating, should be provided. These are also mandated in the class 1 and class 0 and class 1 in the BS part 6 and BS part 7, BS 476 part 6 and 476 part 7. Now, these kind of materials are to be put in the facade area, as I told that this facade is very close to the cause of a fire, because this aircraft is fueled with petrol, and in case of a small spark there will be a fire over here. So, the fire should not get into the building on the air side is the concern. And as I told you, the people on the air side cannot go to the city side. So, people will be panicked and it will be difficult for them to come out of that area, because already the boarding has happened, already the check-in has, they are into the security zone. So, they cannot go towards the other side. So, what is to be taken care? Smoke exhaust, perimeter fire barrier, drenching or to cool the glass during fire. We have talked of drenching, fire drenchers. For tall buildings or high rise buildings, we will again talk on that. Perimeter fire barrier system means there will be a flush of water on the glass facade or on the facade of the airport building, that will cool the material and the fire will not propagate further. In case of fire happening inside, the smoke exhaust fans should be which are louvers at higher levels, should be starting the venting process, and continuously hot air venting and smoke venting in any form keeps on continuing in the airport building. So, demarcation of fire zones, fire exits, appropriate signage, adopting proper building construction practices and following the fire resistance norms are to be adopted or are to be taken into consideration while designing an airport building. Coming to another kind of building which are seen or which are coming up in cities every year. In 2000, very current data 2024, I think we have 25 cities which are having metro stations, which hardly started with 1 or 2 and gradually moved to this value over a very small period of time. Within 2 decades, this change has happened. Now, most of the metro stations we see in urban scapes are elevated or at grade. What is elevated? They are beyond the road level, above the road level. At grade means at along the road, and many cities cannot accommodate it, particularly in the busy crowded areas, and they go for underground metro stations. Now, for metro stations at grade or elevated, it is almost same as that of any public space, but underground, when a metro station is there, the concern is if there is a fire, very difficult to come out from that area, because people are in a tunnel, they are inside a tunnel from where escaping is very difficult. If it is a station, then people can even come out and the smoke can be taken out, fire can be extinguished. So, appropriately the design planning and the planning has to be thought of, considering a case of fire or considering that fire can happen. So, you see this is a structure or the flow of the metro station. When you are coming from outside, you are getting off from a bus stand or a parking or a footpath or coming by cycle, and you are getting dropped off in an interchange zone, after which you enter into an unpaid area which is called the concourse, which may have shops, etc., catering, station management, and you buy a ticket over here. So, you are having a barrier here through which, after which you are entering, showing your appropriate ticket into the zone, next zone, which is the platform zone. So, in this concourse zone you will get some, you will get your ticket, and then you will get into this paid zone, that is the platform zone, and you will get very little stuff, that is for some information and some stuff, and you will be waiting for your train over here. So, this is the zone where the boarding and the alighting happens. Now, before I come to this slide, I show you to make you much clear. We see here there is an entrance from where you have finally entered and you have gone down. This is case of underground metro, we are talking on underground metro. So, you are coming down to this concourse zone and then into the, after the ticketing gate you are coming down to this platform zone. So, now you see here is your platform zone, and here you see is your concourse zone, and you may have come here from this road zone. So, this is where you got off from your other mode, came down to this, bought your ticket, came down to this. So, gradually what has happened, you have come down to a zone where there is no connect with the up, and here from this platform there may be one and there may be two trains or two tunnels, one is taking down, one is coming in this direction, and you are now here. Now, think of a situation, there is a fire here. So, you can see these are some of the figures which are showing the same thing. So, this is A with station with two stacks platforms, assuming fire is on the lower floor. So, you see here there are again two levels. So, below this also there are two more platforms. So, you can see train can be here, train can be here, train can be, there can be various designs, train can be here and train can be. So, in this case again train is in 2-3 points, train can be in 3 points. So, train can be here or train can be here. So, people who are, our concern is saving first the people. So, what are the recommendations? Let us see. So, there should be clear pathway connecting the entrance with the ticketing offices, followed by the ticketing gates leading to the escalator stairs and ending to the platform. So, these should be very straight path, clear path. Separating the ticket area from the pathways for better pedestrian circulation to avoid congestion, that is the second path. Now, these are key informations taken from research papers. Clear separated spaces, sufficient number of escalators and elevators. Though escalators and elevators stop, escalators can work as a staircase. One sided platform is more preferable to avoid heavy crowding during peak hours and to lessen the number of people. Manage the platform in such way that people can see spaces and signs clearly. Now, in the metro station, we are, as I told, there is elevated and enclosed station, elevated and open station, at grade station, or that means on ground level, and other is the underground station which we have taken up. Most of our people will be in the concourse or in the platform, but yes, inside the track there can be, inside the train there can be, inside the tunnel there can be fire. Other areas, the equipment room, auxiliary facility, they can also have cases of fire. Now, the concourse level functions, what are the functional spaces? Public areas, as I told you, the ticketing zone, corridors, that is connecting, straight stairs, lifts, escalators, ticketing lobby, ticket office, station control room, data acquisition room, ventilation fans, AHU, toilets, drivers and crew room. Now, these are the basic components of a concourse. Apart from that, there can be shops etc., because over time these spaces are also getting commercialized and shops etc., are coming. Platform level, what we see? Public area, electric room, auxiliary room, UPS system, telecom room. Tunnel ventilation room, we see auxiliary substation, feeds loads like lighting, HVAC, pumps, lifts. So, you see here again we have pumps, lifts, HVAC, all items which is present in a general building, because now we are underground and there you have to have HVAC system and air change system. So, you have to have air handling unit and the HVAC unit and the ventilation system. So, all these should be supported with such functions or services to keep the people to serve the people with the appropriate environment. So, if you see, these are all created, these views are created. You can see that is the staircase taking down to the platform level, that is the staircase or the staircase block, and here are certain norms which are guidelines given in the NBC. As you see, A, that is the distance from the staircase till the end of the edge of this station should not be more than 25 meters. So, within 25 meters from the end of the train or the end of the platform, there should be a staircase or staircase length of the coach, there should be a staircase immediately within that. Within less than 200 meters, there should be another staircase for movement. So, between two staircases the distance is maximum 200 meters. So, from this staircase to the next staircase, as you can see, it is marked. D is the width of that, width of the corridor, width of the platform, that should not be more than 50 meters, that is less than equal to 50 meters. Now, coming to C, what is C? C is, here you can see the train is there. From the train to the end of the station, it should be less than 15 meters on one way, less than 60 meters for two way. The figure has been prepared following NBC, because in NBC the points are given, but this schematic drawing has been prepared based on that. Now, if there is a fire, then from the entry itself the fire door or the fire shutter should come down automatically. Fire shutter drops automatically in case fire is detected by the fire detection or the smoke detection system. The control panel, you can see here is the control panel, the manual operating box, the shutter, the guiding rail and the emergency escape door. So, this door falls or closes and anyone inside can operate this fire door and come out or escape. Even the people who can come for rescue operation can also enter through this into the underground station. Similarly, as we had discussed in some previous module, we see that there is a smoke curtain that can also come down to guard or contain the smoke within a particular zone, because these are in this kind of spaces compartmentation cannot be carried out, because these are continuous spaces and you cannot create a compartment. So, smoke curtain falls to hold the smoke up to a certain height before it can leak to the next space. Now, coming to the track area, you see there is a tunnel, these are the two tunnels through which the train is moving, and you see where people are standing is this zone, but under that also you see the supply air is coming from the top and discharged in this particular area. So, this zone the people are getting fresh air from the top, and what is happening from this area, the over track exhaust is being pulled up or sucked out, and you can see this kind of installations are there on the top, and this is the actual picture of such an installation. So, this is that one side of this exhaust, and that is the other side of the exhaust, and one side it is pushing fresh air, on the other side it is sucking up the over track exhaust, it is sucking up the exhaust air. So, what is happening? A continuous supply of fresh air and pulling up of the foul air is happening, and this is how the air pressure inside the duct is maintained. Here are sizes of compartmentation mentioned, which are to be maintained, but you can see here the dimensions are 2000 square meter, 7000 meter cube volume, cubical extent, 4000 meter square, 2000 meter square compartment, above height of 24 meter from average ground level. These are some compartment sizes which are mandated in the NBC. They provide the detailed requirement for fire compartmentation in stations, unlike most codes, and the SCDF, that is another country code, specifies the exact areas also. So, coming to, if you see the air sucking and air pushing, you see here this is that emergency access, this is that railway station, underground metro railway station, this is another metro station some kilometer away, 1 kilometer away say. So, you can see from air is pushed by the shaft inside, and this is the train, and the air, warm air is pushed out by the fan from the shaft inside. So, this is from one end of the station to the other end of the station, and what you see here, air is pushed by the shaft inside the station, and the warm air is pulled outside the station from the other end. So, in case of any fire, you can see some emergency access is also seen. You can see here there is some emergency access, that is another track through which another train is moving. So, this is say this direction bound passengers train, this is another direction bound train passengers, and within the station ends there is the ventilation shaft put in, after which there is a connector. You can see the two tracks may be interconnected. I will discuss on that. So, what you see, this is the figurative thing. So, the station here, there is one train on one direction, this is the second train on another direction, and the station, the two platforms are connected intermittently at some points. There are some distance criteria also between two connections, it is 250 meters. B is less than equal to 500 meters, that is this distance to the end of the station. Cross passage fire door, there is a fire door here, there is a, you can see there is a fire door, cross passage fire door is there, and the means of egress, that is the point D, the means of egress is there. Egress within the trainway are to be maintained. So, these are the within the train, these are the point, the doors are the D. So, here you can see this is again another schematic picture. If there is station 1 and this is station 2 and the distance is more than 762 meters, we have to put another intermediate shaft for passenger exit. So, in case of a fire in the fire tunnel, in the train tunnel, then some point should be left for people to be taken out from points here. So, this is the ground level, as you can see the truck is moving here and the stations are below. So, this is the transverse requirement. Cross passageways should be a minimum of 1200 millimeter in clear width and 2100 in clear height. So, this pipe or connection between the two tracks you can see is 2100 in height and 1200 in diameter in its width. So, these are schematic diagrams made. Also, inside the tunnel nowadays or current metro stations is having a ledge, a narrow platform like. So, inside the tunnel, if there is a case of fire, it is called the incident train. What to do? Yes, the best option is to drive to the station, but if you have to stop the train there is a walkway just opposite to the power line through which the people can come out. At that level there will be the doors will be opened and the people can come out and walk to the nearest railway station. So, these kind of things are getting inbuilt within the underground metro stations for evacuation scenarios. So, these are to be known to an architect if at all they are designing or getting opportunity to be a part of a metro station design process. So, here are some pictures from an elevated railway station, and you can see that is the entry to the escape staircase and the fire hydrant moving up serving the building. These are not less than 150 millimeter diameter trunks serving water for the evacuation process or the extinguishing process to serve or feed the wet risers. With this we end the airports. We come and we will be very brief on the industrial buildings or the hazardous buildings, which includes the storage buildings as well as the hazardous buildings. As we all know, industrial buildings are for a very different purpose. They might have various flammable items stored, which we call them as hazardous occupancies, and if we see, they can be categorized under three broad heads. Light hazard, which contains so many types of buildings. If I read one or two, like brickwork, means brickwork to clay work to dairies to greenhouses to poultry farms to vermicelli factories to zinc copper factories, all will glass and glass fiber manufacturing. These all come under light hazard, means the extent of hazard is low. Under the moderate hazard comes aluminium factory, atta and cereal factory, cashew nut factory, hosieries, oxygen plants, that also comes under moderate hazard buildings. The third is the high hazard, which again has two subcategories, subcategory A and subcategory B, where you can see various aircraft hangars, which we already discussed to some extent, fireworks manufacturing, oil mills, sawmills, where immediately fire can move and create a huge loss. These kind of buildings come under the high hazard category, and for each of them we have already studied the basic principles. Storage is very important. Storage of the flammable and combustible material should be as away as possible from the occupants. Mechanical equipments like pumps, compressors, agitators, fabrication activities like welding, cutting, grinding, these are a mandatory part or a inclusive part of such kind of industries and hazardous factories areas. So, it should be of very high risk zone and appropriate fire drill, fire training, fire fighting equipments, egress route highlighting becomes a mandatory part for such buildings. Also, as I talked about electrical wirings, faulty electrical wirings or frayed wirings should be protected with MCBs and they should be installed without any fail, so that they can disconnect the power in case of any high draw of electricity beyond its capacity. So, for industrial zones, fire and hazardous buildings, zones are also demarcated, zones in city plan, city master plan are also designated, so that the fire in such areas do not lead to another fire to some residential areas. So, in these areas, because they are having highly flammable items, they can lead to fire to the neighboring areas, and that is why, because of the radiant heat. So, because of that, these particular areas are to be kept in the zones which are marked in the master plan. Fire resistant walls, floors with appropriate sealing with fire rated materials becomes a mandate for such kind of buildings. Emergency power should be supplied to the various services like fire water pump, pressurization and smoke venting, dampers and actuators, fireman's lift if there is a fire lift, exit signage lighting, emergency lighting, fire alarm system, public address system, magnetic door hold open devices, lighting in fire command center and security room are to be ensured in case of a fire. So, these are the emergency, these are the spaces which should be supported with emergency power other than the regular power supply, because in case of a fire immediately the electrical mains are to be switched off. However, the emergency power to maneuver, to operate all the essentials are to be supported with the from the emergency power. So, these are some things, some of the points which are to be kept in mind beyond the general rules on material, typology, building rating. As you can see in this slide, fire command center which will control the fire, which will act upon when there is a case of fire, should have 120-minute rated wall. Glazings, if at all, should have 120-minute rated glazing system with automatic fire curtain, automatic water curtain system, that means it will not get heated. Surface interior finish, that should be taken care of. So, any kind of flammable paints are to be avoided. Because people will be running away, the level changes are to be taken care of, the slopes are to be considered during design. So, these are the points that an architect should keep in mind while designing a building of hazardous nature, and depending on the type of hazard, the NBC gives detailed outline for each and every part of the space, which I am not, which is already documented, but I raise the major points which one must be aware of before taking up designing any hazardous building. So, here are some on the width of the staircase, on the exit doorway conditions, and these are all written down in the National Building Code 16 Part 4. You can have a look, and whenever you are designing, you have to follow the norms written over there. Here are a list of references, and with this I think we end this module 9, and thank you all.